Hello and welcome to CIT260, Object-Oriented Programming. This is the final presentation for the course. My name is Rob. Excuse me. My name is Rob Wagner. Forgive me, I woke up with the flu this morning, and although it came at the worst possible time, this is due today, so we've got to get it done. So let's go ahead and do an overview. We're going to review some of the Java components of the program for this presentation. We'll demonstrate the functions in a live project demo, as well as demonstrate some of the live images of the code. This project is closely based on the text-based role-playing game Hammurabi, which can be found at www.classicreload.com/hammurabi.html. The difference in our game is that it takes place in the times of Joseph in Egypt in the 7 years before the famine. And as an overseer in Joseph's home, you're responsible to manage the resources for your subjects so that they may survive the years of famine. So without further ado, let's get started. The difference between static class variable and non-static instance variable, part one. Well, first of all, an object-oriented program is made up of classes, and each class is made up of variables and functions that relate to it. There are two primary types of classes or variables known as static and non-static. Static is when you want something to stay the same, such as the map. The map is going to have the same locations available, and in this case, and, and the same images that represent the map. You'll be able to travel to all the same locations, regardless of how much grain you may have or whether or not you've lost some of the population due to mismanagement of resources. So that's an example of static. Non-static is something that may change, like the wheat. You may increase or decrease in wheat as you play the game, and so this variable may change. Here's an example of a static function. Of course, we use the display map in our case. So you can see that, I'm sorry, I keep choking. I just need to get some water. I apologize about that. If I could have scheduled this flu, it would have been a different time. Anyway, so you can see the map class is a static example because that's the one that's not going to change. In this case, the map is a 5x5 grid or array matrix, and we'll demonstrate more of that later. You can see the arrays, array lists, and enums as all different types of lists, and they all have different functions. An array doesn't change in size. It's always the same size once the object is created, and you just reference the elements within that array. With the map array, we used more than one list because we're creating a matrix. And so that one creates actually 25 different possible outcomes. An array list is a variable length collection class, and this one is more used for when you're gathering special inventory items or weapons or livestock. Those things may increase over time, so the list needs to be able to increase to accommodate that function. An enum shares some similarities to an array, as it is a fixed length list, but that's where the similarities end. Unlike an array, once you declare the constants of an enum, they cannot be changed. Enums can be referenced in the switch case, and we're going to give an example of the map here. You can see where the location for the map has one list here and a second list here. So number of rows, number of columns, and each of those is going to have a value of 5. Now we create these loops in order to manage those functions, manage those locations. Let's go to the next page. We'll give you a demonstration here. So with each of these, let's say, and the way we manage those locations, when you want to go to a location, the system will prompt you for an input, and we use an X and Y coordinate type of value. So you put in the X and the Y. So let's say the X and the Y are 0 and 1. In this case, it's that you meet an old wise man in your travels, and he asks you if, and it cuts off, but it says he asks you if you've ever heard of kamut, which is an ancient Egyptian grain. Where in the second example with 1-1, you find a protein bar, add 3 strength to your taskmasters, as this will increase productivity. So there's different options you can have. It's kind of fun to create a unique response for each one based on where you're traveling in the map. Now, how to throw, propagate, and catch custom runtime errors in your program. This is also known as exception handling, very important in programming. We design our programs to be able to receive certain responses from the user, but what if they receive a response that they're not expecting? How do we handle that? If we don't have a way to handle it, then the system, the program may certainly crash. And so we're going to share with you some ways that we've handled that. You usually would wrap a try-catch statement in a do-while loop, and that allows us to continue coming back to it until we get an appropriate answer. So in this case, we have the switch case. So this is for the main menu, and there's 5 options there. But what happens if we enter 0 or if we enter 9? In those cases, because the while says options less than 1 or options greater than 5, it's going to throw an error and ask for another input. So we'll show you how that is demonstrated in a later slide. Why a character string class should be used versus a byte stream class when reading and writing data to a file. So character stream and byte streams have different flexibility, which is useful to know as a programmer, especially when implementing a project that may have global impact where characters can come from any language. So imagine you say character must be at least 2 characters or longer for the name function. Well, what if somebody in China, they have just maybe the one character for their it's called kanji or their Chinese character? It would throw an error, and that's not a good experience for them. So we have to have a way to handle other characters as well. This is one of the ways we do it. So how to write character data to an external file. In object-oriented programming, we can actually create files, assign the data to those files as a type of saved game. This allows players to stop and resume their experience when convenient so that they do not have to complete the whole game in one sitting. I'm going to go ahead and jump over to our program to give a demonstration. So I already clicked run. So let me go ahead and do that again, though, just so you can see it from the beginning. So here's the welcome message. It basically goes over the game. It tells you what you can do, what your objectives are, what's your role, and then it asks you for your name. So I'm just going to put Rob in menu. So remember here, we wondered, how do we handle value or greater than 1 through 5? Let's enter 0 and see what happens. If we enter 0, it says error invalid option, but then it comes back and asks you for another one. Again, it's an error invalid option. Let's say that maybe we're new to this game. We'd just like to get some help on how to play. So to press 3, menu. How do I view the map? Maybe that's a good question. And so we could study that. Or maybe we want to go back to the main menu and say, maybe I don't have time for this right now. Back to the main menu, you can see the option 5 here is to quit. So if we want to quit, we just hit 5, and then it closes the program. So, so there's a demonstration, short but sweet, and believe it or not, there's really months of programming that went into that, just that little demonstration there. So in conclusion, object-oriented programming is not easy, so keep practicing. I had challenges in this journey. However, I'm thrilled with all of the knowledge I've gained in this course and will continue to gain as I keep practicing. One final note for anyone who's in college or learning or wants to learn, I think knowledge is the greatest wealth ever. You earn it once and you get to use it for the rest of your life. And it's the only wealth that continues to grow as you use it. So learn something new every day. Thank you for being here.